All right, so example or scenario three. There's a box of crayons. It has one red, one yellow, one green, and one blue crayon. If you take two crayons out one by one, so you take out a crayon, you take out another crayon. Then in how many unique pairs of crayons? Then how many unique pairs of crayons can you pull out? So we could do this by writing all this stuff out, but let's just make it shorter at this point. So what you want to do is let's pretend we're going to take out one, two, three, all four crayons. Now, how many combinations can you like? You can do a red, a yellow, and then a green, and then a blue, or you can do a red, a yellow, and then a blue, and then a green. But the shortcut to figuring all those possible permutations of all four being pulled out ooh, would be 4 factorial, which means 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24, times 1 is 24. This is 24 permutations, 24 total permutations. So when you choose 4, right? But we don't really choose 4. We're taking 2 out, right? So we got to get rid of that one and that one. So instead of 4 factorials, we have to get rid of these last 2 turns when you had 2 left to choose from and then 1 left to choose from. So 4 times 3 times 2 times 1 over 2 times 1. Sorry, I was thinking about something. So in reality, out of those 24 permutations of 4, they really help us. Like, there's really only 12 combinations of 2. So, if it helps, because as the more you get, the more you realize you don't need. Like, we didn't need all those letters before, and now we're realizing we don't even need this step right here. This just tells you how many total combinations we have. This helped you understand, but at this point, you don't need it in order to get the answer. If you can write the original, like if you had 4 turns taking out crayons and you take out the last 2 turns, that's what it helps you really see. Then you're only left with 12, permutations of 2 turns. We'll say like when or we'll say turns or takes. But remember, like if you do these, this is like what it's really trying to say right here. The 12 with 2 turns, you can get like red, yellow, red, green, red, blue. You can also get yellow, red, yellow, green, yellow, blue. You can also get green, red, green, yellow, green, blue. You can also get blue, red, blue, yellow, blue, green. So we don't have to write these all out, but I just wanted to show you. So remember that some of these are going to repeat because we have red, yellow, but then we also have a yellow, red. So for every combination of 2, how many times can it show up? So that would be 2 times 1. So we get 2 permutations of 1 like unique combination. So we take the 12 permutations of 2 and we divide it by 2 because that gets rid of the repeats. And we end up with 6 unique combinations. Alright, so let's see if we can shorten the work even more. Okay, so you have 6 friends with different names. You put their names on a piece of paper and you randomly pull 3 names to form a team. How many unique teams of 3 can you form? So we know that if we did all six, it'd be 6 factorial. Like we can choose six, then we can choose five out of them, and then we have four left to choose from, and then three, and then two left to choose from, and then one left to choose from. But we're not doing, we're not picking six people. We're only picking three people. So we got to get rid of the last three. So 6 times 5 times 4 times 3 times 2 times 1. And we need to get rid of or undo the last three chosen. So here we go. So 6 times 5 times 4. That's 30. Times 4 is 120. 120. So remember, we skipped that first step right here. So we actually have 120 permutation of 3. Now, any combination of 3 can be represented 6 different ways. 6, let's see how we put it. Permutations. 6 permutations per one unique combination. That means the combination can show up 6 different ways. So you do 120 divided by, or we're going to take away all the repeats. I'm going to go back real quick. 6 permutations per one combination. If it helps you, you can get rid of that one. So we're going to get rid of 120 total permutations of 3 divided by 6, because each one combination has 6 of the same, basically. And we get 20 unique combinations. 6 combinations. And I assume that you don't need me to do this last one. Thank you.